Alright, so today we're going to do more quadratic applications. Again, these are level 2 questions. This time I'm going to give you the equation describing the motion of an object or the growth of an object and ask you some questions about that equation, analyzing that situation. So in this case, John is hitting baseballs. The height and feet of the ball is found using the model h of t, so height in feet is equal to negative 16t squared plus 25t plus 5, where t is seconds. Of course, in the calculator, that's going to be the x variable, but here we go. So seconds after it's hit. So we first want to get a good picture of that. So I'm going to go to my calculator and put negative 16x squared plus 25x plus 5 in my calculator. And I'm going to draw it and see what I see. Okay, so in my last window, it was I have all this extra space because here's my parabola pretty far down. Let's think about baseballs. If I press window right now, my baseball is not going to be in the air for negative 20 seconds or even maybe positive 25 seconds. That's almost half a minute. Baseballs don't stay in the air that long. I think I'm going to go in closer to 0 on that, negative 10 to positive 10. Baseballs won't go negative height. Y is height, but I'll go ahead and leave it so we can see the x-axis.
Please come to the main office. Mackay, Speed, please come to the main office.
Okay, and think about a baseball. A baseball is probably not going to go 250 feet high in the air. Obviously, we saw it that it did not. There was a lot of extra space at the top. Let's go to 50 feet. And see if we can see a better picture. Sure, there we go, there's a little better picture. So let's answer the questions using that picture. What is the maximum height that the ball reaches? So maximum, and then height is the y. So, where is maximum? Remember on a Casio, maximum is going to be at F5, and in a TI, it's in second and trace. Same place that intersection's found, just not the intersection. So here's my Casio. Maximum is F2, so I'm going to press F2. And there we go. Maximum height, 14.766 feet. I know it's Y because it said height. I don't need to write the X for the answer to that question. Okay, let me get my TI going to help you guys out. Okay, change my window like I did on the Casio. Okay, so second trace, maximum is number 4. Now remember, it asks you to click on the left side of the parabola, which it is, and then you have to arrow over to the right side of the parabola and click enter again, and then enter one more time to get rid of the guess before the TI will give you the answer. Okay. Part B, when does the ball hit the ground? This one doesn't seem like they've asked a question because we can't see the number. But you have to think to yourself, if you've hit the ground, what's your height? 0, right? So to answer this question, we need to make the height, or the y, equals 0. So that means we're going to put 0 into our y2. I'm sorry. 0 into our y2 and draw the graph. Remember, that zoomed across a line at 0. We can't see it because it's the x-axis. But now we can find the intersection. at negative 0.179. Or second, trace 5, move the cursor to the other side. There we go. Press enter, enter, enter. Or 1.742. All right, now if we think about this being a baseball, you can realize that they're both not possible. If you think about a baseball, then a baseball does not have a time machine, so this negative value doesn't make any sense. You can't be at negative 0.1 seconds. So this one we cross off as not reasonable, and this one we label as seconds. Okay, third question. What if I ask you a specific x value? Find the height of the ball after 1 second. Seconds is x's. So if I need to put in an x value into my equation, then I'm going to put this x value in the same way I always put in x values, with F1 on my Casio or trace on my TI. I'm going to go back to y equals and clear out that 0, and then graph. Trace 1 second, enter, 14 feet. Okay, and last question, hiding underneath. There we go. When will the ball be 10 feet above the ground? Remember, feet is a y value, so this is something that needs to go in y2 so that I can find the intersection again. So again, go back to my y equals, down to the second row, put in the 2. Nope, 10. Why do I keep wanting to put in a 2? 10, graph. We see 2 intersection points, so we want to make sure we get them both. So second, trace 5, enter, 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 0.235, x equals 0.235 seconds. Oops, don't put a t in seconds. And then remember to repeat yourself. Second, trace 5, move to the other side before you press enter, enter, enter. The answer on the right is 1.327. Both x's are positive, so both x's are valid. One on the left, one on the right. Both of them need to be there to be complete. All right, let's try one more example. This one's written in a slightly different way. This time it says for the years 1971 to 2001, the number of films produced is y, the number of films is y, can be modeled by the equation y equals 10x squared minus 94x plus 3,900, where x is the number of years since 1971. That's going to make a little bit of difference. So I'm going to put that into my equations, into my calculators, and let's find a good window to see them in. Okay, because of that number on the end being 3,900, I don't see anything when I just draw it. So we need to make this window way larger just to get started there. Remember, x is years since 1971, so 0 would mean 1971, 10 would be 1981, 20 would be 1991, 30 would be 2001. So we should at least go up to 0 to 30. into our X window. So I'm going to press window. I'm going to keep the negative 10 just so I can see this side there. But I'm going to make my X max, let's make it bigger than 30 so we see everything. Let's go with 40. Minimum Y, that's the number of films. It would never be negative, but we might as well leave it. And the number in the math problem is 3,900. So let's make it bigger than that so we can see everything. I think I'll try 5,000. It's a good starting place anyway. Well, I don't see anything, so maybe it's even higher. Well, now I'm worried about if I typed it right. Oh, nope, I didn't. Oh, goodness. The rest of the math problem from the last problem was out of there. Whew, there we go. All right. If I'd started with my Casio, I would have been fine. So, window. I made that 40. And I made this 10,000. Okay, there we go. How many films were produced in 1985? So, since we're counting the years since 1971, we'll subtract 1971 to figure out that that is 14 years. So we need to make x equals 14. If I'm plugging in an x, then that's either using trace or F1. So if I put in 14, I get 4,544 for the number of films. So minimum number of years, or minimum number of films. So remember, minimum is an F5, and we need F3 this time. In what year? Years are the X's, so that's going to be that 4.7. Third question. What's the smallest number of films? Smallest. That sounds like minimum again. But this time, number of films, remember, is the Y. So we just head back to that minimum we just found, and we write down the Y part. 3,679. 0.1. Remember, it's a model. It's not going to be perfect. So about 3,679. And then what's our last question? In what year were 4,200 films produced? Films. Films are Y. If we have a Y to put in, remember, put it in Y2. So Y2, 4,200. Zooms across there, and we find our intersection, F5, F5. Now that first one's negative, so that's not in our range. That would be 4, 1971. This one's in our range. This is the one we want, 11.9. 17. So that's about 12 for the easy math here. Let's make that 12 years. So in what year? That's 12 years since 1971, when our math problem started. So that's 1971 plus 12, so 1983. Okay. Sometime during 1983, or right at the end of 1982, I guess, would be when that 4,200 would be predicted to happen. All right, ask questions as you need to in class. Thank you.